start. So I'm working with Styra. I was the first employee here in Europe back in September. Then Anders joined me here in December together with Stefan in Berlin, and we are gradually building out our operation in Europe. We recently signed an agreement with a Dutch distributor called EMEA that some of you might have heard about. I'm just going to give you a short overview of what OPA is and what Styra does. So OPA is an open policy agent, and the whole idea is to build a policy agent that could be used across the stack, mainly in a cloud-native environment, but also for other applications. So we are covering many different use cases, and our customers use us for all these kind of use cases. So the most common use case is probably Kubernetes container admission control and container management. That's very pre-packaged. We will not talk about that in depth today. Maybe Anders mentioned something, but it's something we can come back to talk to you. The two other use cases that are quite common is the microservice and application use cases. Is how we protect API, how we externalize authorization from your applications, or how you do authorization at scale in a microservice environment. Is here where Anders will do a little bit more deep dive in his 35 minutes. Other use cases we cater for is your CI/CD pipeline. Who can approve something that moving from one stage to another? We can make sure that you are not allowed to enter code from your personal Git into the company Git and something like that. Typically use cases as well. And we also see emerging use cases in filtering of data. See just an application maker selects all call, we fetch that and we add some filter dynamically to make sure you only see the data you're supposed to see. And also we do public cloud with Terraform. That's another third or fourth common use cases. I talked a little bit about the common use cases. There is an OPA survey out there. Please have a look. It's published on openpolicyagent.org. And here you can see the most common use cases, as I talked about, is the Kubernetes, is the application, is the microservices. What's also important to understand is when you're starting to use OPA, people tend not to stop with one use cases. A majority of our customers or users have more than one use cases. This is a survey we did back in May. We're just launching a new one. Then we asked 150 organizations. We know by today that it's more than 350 organizations using OPA, and 50 of them or so are paying customers of Styra. And we are the creators of OPA. We're just not a sponsor. We did write OPA and release it to the open source. We did that in 2016 as a CNCF project. So we entered the sandbox in 2018, incubating in 2019, and hopefully we will add to graduation now in 2021. And it's also very lively community. It's over 3,500 users on the Slack channel. It's over 30 million downloads, and we know today that it's at least 7 million OPAs out there in the world, making decisions every minute, every second of the day. And that's where we come in as Styra. We of course sell, as every open source company, support on the OPA. So if you have OPA, need support on that one, need training, need someone to discuss with, please reach out. A lot of Anders' work is done there. But we also have a management control, because I said you have not one use cases, you probably have not one OPA. Our current customer have everything between 10 and a few thousand OPAs out there, and then you have a management issue. And there we have our Styra declarative authorization service, which actually is a management control plane, either as a software as a service, or you can run it on-premise, where we help you, give you a perfect environment to write your policies, do your version control of your policies, test and impact analysis of policies, distribute so you make sure the right set of policies and the right data comes to the right OPA. And we also do health checks on the OPAs and do a central logging. So that's what we help you. And there are other things out there that you could look at. If you're interested, join a Slack channel. There's a Styra Academy. I will probably send it out, or Pete will send it out, where is a 30 online lessons how to write policies. And yeah, I think that's where I'm going to stop. So I give time over to Anders. I have 5 minutes more or less. Okay, Anders, over to you.
All right, thanks, Gustaf.
Stop share.
Yeah, and I'm gonna start my share then.
Perfect.
So can you all see my screen?
Yes, we can.
Awesome. I'm just gonna get started. And so yeah, so as Gustaf kind of introduced OPA there, and we'll have a kind of take a deep dive here in where OPA fits in. And just as Gustaf said there's hundreds of use cases for OPA release. But since this is an API community, we're gonna go deeper in that space today. So we're gonna be looking at the evolution of access control in the API landscape. And of course, access control isn't like an isolated island. You kind of have to get identity in there somehow too. So we're gonna cover both of those today. So first off, just some words about me. I'm Anders. I work as a developer advocate at Styra. I have a quite long background in software development and identity systems in particular. And I've been active in the OPA community for the last 2 years or so. And when I'm not coding or working with OPA, I'm interested in cooking, food, and football. So that's me. Okay, so first, let's look at kind of the model we came from, the monolith application. And moving from monolith to microservices isn't that big of a step, at least not from a PowerPoint kind of view. It's pretty much just removing this surrounding box and having these modules or communicate through network calls rather than function calls. But of course, we still need the same kind of functions. And the ones we will focus on today is going to be authentication and authorization. So let's start looking into the evolution of identity. And of course, the old model, or the monolith model, I shouldn't say old, it's still a pretty pervasive model, but in the monolith model, you have one application and it kind of handles everything. So in terms of identity and access control, the user just hands in their credentials, they log in, and the application kind of tends to all these talking to the user database, the permission database, and eventually once the user is authenticated and authorized, we delegate, or they forward a request to get some actual data. So that's the model. And in our distributed application, or the microservice one, we normally delegate this responsibility. So we cannot say this is not the responsibility of the app. But up until now, we kind of did not do this for access control. So we delegate authentication, but we still do authorization in app or in our application code. So it's kind of coupled to application logic. So when we kind of move over to microservices, a naive architecture would look something like this. What we see here is pretty much just the monolith model moved into multiple services. So the user still provides their credentials to the service, and each service still does all of these lookups. So they authenticate the user by checking that the credentials are correct and the user exists. And then they make another call to the permission database to check that the user is authorized. And of course, as you can probably just tell by looking at this schema, is that this model doesn't scale at all. And the more services you add, the less it scales. So what can we do about it? Well, we can start identifying some of the problems here. And one, of course, is all these calls to the user database. And another one is sending around credentials like this. So is there really a need for my backend service talking to the database to know the password of a user? No. So one evolutionary step here would be to delegate, kind of move away the user database to an external system, an identity system, and have the user go there with their credentials. So they authenticate to the identity system and they get a token in return. And that token is then passed around between these services. And they no longer need to care or to manage the identity of the user, because that responsibility has been delegated. And of course, when we say users, we're not just talking about humans here or like normal, but there are all manners of devices or clients in modern API services. So we need a system to kind of cater for all of these users. And that's pretty much what OAuth 2 is about. It's about delegating responsibility for this, have a token passed in return, and that token then transferred or carried through these microservice landscape. So what OAuth 2 does, just a short reminder, it defines a set of flows for a user or for these robots or devices to authenticate at the authorization server or our identity system in order to obtain access tokens. And so access tokens is what we use for identity or for authentication rather than passing around our raw credentials. It doesn't really say what the token is or what it should look like, but that's we will look at in a bit. And even though it's called an authorization framework, it doesn't really provide a lot in terms of authorization. It mainly details these flows, like this is how you get a token, and there's some basic concepts of authorization, and OAuth calls these scopes, meaning that you say like, I want an access token and I want it to be valid for these scopes. I wanted to use it for reading files in this system. And in that way, it's somewhat about authorization, but it's a pretty coarse-grained model. And of course, pretty much anyone who has used the internet in the last 10 years have knowingly or unknowingly used OAuth in form of these social logins. So if you log in with Facebook, log in with Google, etc., you are using an OAuth flow. Of course, again, OAuth didn't say much about what a token is, and OAuth neither does it say much what a user is. So in order to kind of formalize that, OpenIDConnect adds an identity layer on top of OAuth. So what OpenIDConnect adds to OAuth is, among other things, an ID token and a user info endpoint, providing details on the user. So we have some standard claims, for example, saying like, and a user has an email address or a phone number or a physical address. So it's pretty standard stuff, but it's good to have a standardized way of dealing with that and not having to kind of roll your own. And OpenIDConnect also adds a whole bunch of other things like metadata, etc. And many of these concepts have also later been kind of backported to OAuth 2. So that's where we are in terms of identity now. And again, OAuth didn't say much about this token. OpenIDConnect does define the ID token, but the access token, what is it? And how would our apps know what to make of this? We kind of said before that it's good to cut out the credentials. So we're no longer sending around passwords. So rather we're sending around tokens. But if a token just says like ABC123, how does our app know that this is an actual user? Well, one way of doing it is, of course, to take the token and ask the identity system. So if I get a token and it just says some opaque identifier, I can ask the identity system, who is the user behind this token? But of course, now we're starting to draw all these arrows once again. We're starting to add network calls. So we didn't really win much. If this is our model, we're kind of back to where we started with these monolith apps, or the naive model, as we called it. So don't do this. What we'd rather want is to have our tokens carry the data that we're interested in. So any app receiving a token can just look into the token and say, hey, this is Anders, or this is Gustaf making this call. And any other claims which could be useful. And normally that would be the groups you are in, but could be pretty much anything. It could be your department or your shoe size. It doesn't really matter. That's up to the identity system to provide. But any of these claims we can use for access control. And another benefit of this is, of course, that these tokens can have an expiry time. So, and which would be pretty annoying if we did for passwords, for example, if we had to change your password every hour. But there's really no problem in changing a JOT every hour, or changing what a token is. And some other attributes of JOTs, they are immutable, so we can know that they can't really be tampered with along the way, or else the signature verification would fail. And of course, being such a pervasive standard, JOTs are pretty much everywhere. So we have libraries for encoding and decoding and working with these. So now we kind of have a pretty good model for dealing with identity. We still have a little caveat here that we should probably mention, is that sending around JOTs, again, this is both the good thing about JOTs and the bad thing about JOTs. Their contents are readable, so anyone can just have a look at the JOT and see what's in there. And while we want this for our services, these JOTs could, of course, contain sensitive data. They could contain personally identifiable information, for example, that we might want to use in our services for access control, or for logging, for debiting, or what have you. But it might not be information that we want to share with the user. And another problem with JOTs, or sharing JOTs externally, is that you might create some couplings there, because if a mobile app developer sees that, hey, the username is in this JOT, I can use this in my app. And of course, they're gonna build integrations using this. And 2 years later, we might decide that the username attribute was misspelled, or we want to change this into something else. And then we unknowingly would break all these integrations relying on data we put in our JOTs. So be careful about exposing JOTs on the outside. They're excellent for transporting attributes inside your systems, but do consider means to not share JOTs externally. And some possible mitigations for doing that was to instead issue opaque tokens, like these ABC123 tokens. And then once those tokens enter your perimeter, you have them exchanged for JOTs. So we kind of get the best of both worlds there. You have opaque tokens externally and JOT tokens internally. Another thing you could do, of course, is to just limit the data that you put in JOTs. So maybe you can just put the username and an identifier of some type. But again, then you might be in that position that you again need to do lookups, which you'd rather avoid. Encrypted JOTs is another option, which does that pretty much in terms of complexity, though. Let's see here. Okay, so we now start to have a pretty good model for identity and authentication. We kind of cut out at least half of these network calls. So what about these then? We still have one lookup in each service, and that's after we established identity and we said, okay, we know for a fact that you are Anders, but what are you allowed to do? Then we still need to make this call in each service, or at least any service of importance where you need permissions to do something. And one way of dealing with this is to just do it in the front of your kind of API application. So you put a gateway or some sort of ingress in front of your services, and you say, if you made it past here, then you're allowed. So you just make one check. And that would be in the gateway where you would do some routing and maybe some basic controls. And of course, it's a good model in terms of performance, because you only need to do one lookup, and then you can kind of and then the other services, they don't really need to care because they know that the gateway took care of this. But of course, a problem with this model is obviously that you might have traffic, or you might want to do things which is not really covered by the gateway, where you still want to do authorization checks. So you might have a cron job running inside of your cluster, or you might have internal users, or you might have other types of users, even externally, that for whatever reasons don't want or should go through a gateway. So in those cases, you'd still need to do some access control in your services. And another model is to put it in the back, or because what you really want to protect is often the data, especially for API style applications. It's the data that's where the money is. So you put your access control down there. And of course, and this is something we've seen a lot, like once you start building all your things around the data, you kind of reinventing the monolith in your backend, because now they're doing authentication, authorization, and pretty much and some form of orchestration as well. So yeah, I would rather not do that model either. And that's kind of where OPA enters the picture. So some of this, of course, Gustaf already mentioned, but what OPA is an open source general purpose policy engine, meaning you can write policies about anything. It doesn't need to be strictly around authorization, but you could just as well think of it as an oracle, where you, based on some policy, you ask it questions and you get responses back. So a normal question would be, am I allowed to do this? And OPA would say yes or no. But it might just as well be about, I'm in this department, what's my expected salary, or something like that. So it's a truly general purpose policy engine. And what this entails is that it decouples policy from your business logic and from your applications. So normally in a monolith, or maybe in a small microservice environment, you'd have your policies kind of hard-coded. So you'd say in code, if user.role equals admin, then it should be allowed, etc. Of course, the problem with this is once you start scaling, it becomes kind of problematic of changing or working with these policies, because they're all they're all coupled to code. And the more teams you have, the more technologies you involve, the more complex this is going to become. So just as we kind of decouple storage and data management to databases, OPA can be seen as the database of policies, or the decoupled concepts of policies. OPA doesn't really do enforcement though. That's still up to your application. So you can ask OPA anything and you get an answer back. But then what you actually want to do with that, that's still up to your application. So,
Anders, just a quick thing. There is a little bit sound issue with you. We hear you quite well, but there is some beep coming in. So if you stop your video, it might help out.
Sorry, yeah. Let's see here. Okay, I stopped my video. Does it work better?
Absolutely.
Yeah, for me too.
Perfect.
Great. Okay, I hope I didn't last for too long, did it?
No, but it was the minor issue, so no worries.
Okay, great. I'll just carry on then. So policies, they are written in a declarative language called Rego, which we'll have a look at just in a few minutes. And since OPA is a general purpose policy engine, we have use cases ranging from Kubernetes, Microservices auth. You can use it for data source filtering, Kafka authorization, and CI/CD pipelines, and what have you. You can really, whenever there's policy and authorization, you can pretty much use OPA. We have a very active community around, I think we're like almost 4,000 on Slack right now. We have hundreds of integrations. So again, if you're using PHP, or if you're using Java, or if you're using Clojure, or whatever technology you've invested in, chances are pretty good that there's an existing integration for you. And if there isn't, it's normally not too much work to have one added. Okay, so we're kind of redrawing the map of access control here, and we will now see that for each of these services we add an OPA pretty much, and these OPAs are all connected to a bundle server, like where we store policies and where we store data. But as you can see here, we can we flipped the direction of these arrows. So the services are no longer calling the permission database directly, but this is rather pushed through the applications, or rather to the OPAs. So for each of these requests, there's no longer a need to reach out to the permission database, but that's handled by OPA. So deployment-wise, OPA is a self-contained binary, and normally the normal way of running OPA in a microservice world would be as a sidecar. So you just start OPA next to your application. If you're running in Kubernetes, you'd probably run it as a sidecar, which is another container running in the same pod. But there are other deployment scenarios available too. Policies, and that's where the fun is, which is, again, this is policies are written in this language called Rego. It's a declarative high-level language. So it's kind of like SQL. You describe what you want rather than exactly how to do it. And a policy is pretty much a number of rules. So you just say, based on this or that rule, I will either allow or deny this request. And rules are normally say yes or no, or true or false, but can really return anything. So you can return a complex JSON object or a string, or maybe you want to add a reason why somebody is denied because they are not an admin, for example. So you want to tell the user why their request was denied, so they can do something about it. And Rego comes with a unit test framework. So it's easy to test your policy in isolation. And again, this is all decoupled from your application code. It's a very well-documented language and a very well-documented system. I encourage you all to check it out later. And there's also a playground where you can work with Rego online without downloading anything or so. So I'm not sure how we are on time here, but I think we have time to do a quick demo.
Yes, we still have some time.
Yeah, just before
and in
that.
the meantime, if people have already questions, you can already ask them to the chat. Then we will later on then ask them to Anders.
Yeah. All right. So what I'm going to do here is I'm going to create our first policy. I'm going to enhance here. You can still see my screen. Can you?
Yeah.
Okay, great. Okay, so 5-minute introduction to Rego. We're going to create a very basic policy here together. We're going to do it from scratch. So any policy is going to be part of a package. It's kind of like a namespace or package in Java or what have you. So I'm just going to name it policy, and we're gonna make a very basic policy, which says that by default, the allow rule here is going to be false. So if we are to push this policy into our OPA now, no matter what we ask OPA, it's going to say that allow is false. So that's not particularly useful, but it's a pretty good default. So now we can build something on top of that. So of course, we're going to want to add a rule where something makes allow true. So the way Rego works is you first state the name of the rule, and then you add a body to that. And if all of the conditions in the body is true, then the rule is true. So we're going to say here that if input, and if we did something like username Anders, if this is true, then the condition here or the rule is going to be true. And if we add more conditions here, like role is admin, then all of these are going to have to be true for allow to be true. What we could also do, if we'd rather want to do one of them would have to be true, then, so it's kind of like an or. So in this case, if either the username in the input is Anders or the input role is admin, then allow is going to be true. Of course, we should probably not have rules work directly with usernames, but you'd rather use roles or so. So that's what we're going to do here. We have a very simple rule. Again, by default, allow is false. But if we provide as part of the input, meaning when we ask OPA, we can ask it. We can also provide data. So we say, I am an admin. Am I allowed or not? And then OPA will respond based on that. So in this case, we are not allowed unless we provide a role in the input, and that role is equal to admin. So again, OPA ships with a unit test framework. So we're going to write a very simple test here. I'm going to call it policy test, and we're going to add it to a package, and and the way unit testing works here is pretty much the same syntax. The tests are also just rules. Allow false by default. That would be a good first test. We're going to say that if we don't do anything, allow should be false. And we can say that in terms of not allow. We could also do allow equals false. But I think not allow reads somewhat better. And we could also test that allow if admin. So if we provide a role and that role is admin, we should be allowed. And of course, in a unit test, we don't really have a way of providing input. So we're going to have to mock that. And in OPA, that would look something like allow with input dot role as admin. And of course, I just realized we need to import policy.allow here. And now we should be able to run these tests. So we just say OPA test, and we, oh, sorry, I forgot. And we can see that both of these tests are passing. So that's the 5-minute introduction to Rego, the policy language. And I think if you're familiar with any programming language, this is not going to be a big challenge. It's a couple of hours to get like the basics right, and then maybe a couple of days to really master the language. But that's the kind of investment you need to do. So that's Rego, and that's OPA. And so we can have zoomed into policies there, but we still have data, of course. We can't always provide all the data as part of the input. If we can, that's excellent, because then we don't really need to deal with data. But of course, many permission systems, we have millions of records. So we need a way to work with that data, not just in input, but also with external data sources. And OPA has a number of ways to deal with that. You already saw the input way, but we can also pass these JSON web tokens, which we of course talked about before. We can serve data as bundles to our OPAs, where the bundle server kind of packages data and pushes it out to all the OPAs running in our environment. Or rather, the OPAs pull the data. We can also push the data if we'd rather do that. And we can even, from inside our policies, we can use the HTTP send built-in to go to an external source to obtain data that we might need for a policy decision. And of course, the last step here is the actual bundle server. And OPA ships with a number of management APIs, which allows for any OPA instance to reach out to an external endpoint to fetch policies, to report its status, and maybe even to fetch configs. So it's both a distributed system and simultaneously allowing for central management. So now we have these arrows again pointing back to a central system, but these are all like asynchronous. So it's not like these are blocking requests anywhere. But not only does our OPA kind of reach out to obtain policies and data, but it also reports back. So any decision taken by an OPA, if somebody is not allowed, or if they are allowed, OPAs will always report back and say, this is what happened. So you have one unified way of dealing not only with policies, but also a unified way of dealing with decision logging. So you truly know what's going on in your systems, and whether there's a breach or whether there's some error somewhere preventing authorization from taking place. And of course, now when you can nail down this whole environment now, as Gustaf were talking about before, there's really no need to stop there. You now have this unified way of dealing with policies. It's not, why limit that to just microservices? If you're running Kubernetes, you're probably going to want to have this same policy language dictate policies for that. Or if you're using it for, I don't know, Jenkins or GitHub or GitLab, you probably have some informal or formal policies for what is okay to deploy in your environment. So that would be another excellent use case. Or even for infrastructure, that you can't create instances of a certain type, because that would be too expensive, or you need to at least create replicas in multiple availability zones, for example. That could be another policy. So this is the beauty of a unified way of dealing with policies. You have one way of talking policies across the stack, no matter how many programming languages you have invested in, and no matter what kind of technologies you have in your stack, and no matter how many teams or services there is one unified way of dealing with policies, and there's one way of dealing with access control. And that's where OPA fits in. So with that, where do we get started? I'd suggest we start small. So maybe just try OPA in some simple application. Just as you saw the demo here, writing a simple policy is not very demanding. Just try it out. Write a simple policy, write a couple of tests, try it out. Go and check the OPA docs. Again, they are probably one of the better documented open source projects that I know of. And once you feel comfortable, just try OPA in some application that is close to you. You can start really small. Just take one microservice, or take one REST controller in an app. And instead of having the app do authorization, you ask OPA what to do. And once you've done that, you can start to scale up. Maybe look into these management APIs. Where do you want to store your policies? How do you want logging perform, etc. And for learning Rego, you have the Styra Academy, which is a free resource where you can go and learn the Rego policy language. And of course, you're very welcome to join us in the OPA Slack community. That's a great resource. And let's see here. I think that is it.
Thank you.
Did I make it on time? We still have 9 minutes. So
yeah. Thanks for the good presentation. We already have a couple of questions from the audience. For the others, you can feel free to also add your questions. First question, and I will combine a bit the question of Tom and Kalin. It's basically how they have to position OPA and Styra versus a number of competing products like PlainID, WSO2 Balana, Allset Force, Axiomatics, etc.
Yeah, Gustaf, you're muted, but I can see
you. I was muted, but that's really a question to me. And one way of looking at it is it's the same in that way that we also are a policy-based authorization tool. But I guess the similarity stops a little bit there. I think the main difference is the use cases. They do more from an identity and access management. We do identity and access management, but we do so much more. We do admission control for Kubernetes. We are much stronger, if you like, in the cloud native and developer landscape. So all these use cases. The other thing I would say, even if I shouldn't be bragging here, that is adoption. We have over 7 million OPAs out there, as we know of. 350 organizations are using OPA, and over 50 of them are customers to Styra. And this is something we have built up in 2.5, 3 years. So the adoption is quite big there. And I also would say, if you compare it to SACML and Alpha and things like that, is the flexibility. So they are much more closed. You can do certain things with them. We can do everything that they can do, but we are open because I don't know you mentioned that, but we can consume any JSON you send into us as a question, and we can construct any JSON back. So we're much more flexible in that way. Yep. Is that the answer for the difference between plain Axio and WSO2? And yes, the most important one, sorry, is we are pure open source. So OPA, just download it, start to play with it at any time.
For me, that was a good answer on the question, and otherwise the audience can react to the chat. I have a question from Michael. It's about the maturity of open source contributions to OPA, like the Kafka plugin, how to position the maturity of them.
Yeah, of course. In terms of these integrations with other products, I think it largely depends. There are again, I think there are like 50 integrations listed on the OPA page currently, and that's just like the tip of the iceberg. So I think it depends largely on that. But most integrations, they're not that complex. So what OPA does is pretty much it takes JSON in and it responds. So what your integrations need to do pretty much is just dealing with formatting kind of a question to OPA and then deal with the response. So I think even if some of these integrations aren't that mature, perhaps it's not like they have to do a whole lot. So yeah, I don't think it's been a big problem with kind of broken integrations or anything like that.
And I would also add that as one of the differences, the number of integrations that are out there. And this is just from the openpolicyagent.org. Go in and look at, I think it's integration is called a tab, or ecosystem is called, and there you see all the integrations that are built by the community.
Then I also have a good question from Peter Herulen, who basically asked if you delegate all the authorization to OPA, then basically OPA needs to have a lot of applicative data to make the decision. So where are you basically drawing the line?
I didn't really get the question. Gustaf, did you? Or?
No, it's just a question because will you do everything, all the decisions push to OPA, or is there some decision OPA should take or something that should be taken elsewhere, I think, because otherwise you might flood the OPA, or you might need to flood it with data or something.
You get the question, Anders, or?
No, not really. Can you just repeat that?
If you open up the chat, you will see it written.
Oh, sorry, of course.
Yeah.
It's a question where to use OPA and where to not use OPA.
Yeah, because there's of course a thin line between security logic and business logic.
Yeah, of course. Yeah, sorry. Now I got you. Yeah, it pretty much depends on what you would refer to as policy. Of course, not every if and else clause deserves to be kind of decoupled from application code. So I think for the main use case. So yeah, for your example there, which tweets I can see. Yeah, I think that would be something you definitely could delegate to OPA if which tweets you can see is determined by your role, or if it's pretty much an authorization decision. But if it's more like which tweets you're shown based on, I don't know, what you normally would like or something like that, then you're kind of more you're starting to more transition into like normal application logic. And of course, OPA isn't like a general purpose programming language. It's not meant to be that there. But of course, if you can't see a tweet because some user blocked you or something like that I think could definitely be considered a policy decision.
So I think it's the famous architecture answers. It depends a bit.
Yeah, of course. And just as you would externalize like data storage to a database, it obviously doesn't mean that you can't do anything related to data in your applications. That's really not what this kind of decoupling you don't need to go all in. I think any architecture that goes all in is doomed to have to have some problems.
Yeah, exactly.